Alright, here we go. Variables on both sides. I know you're excited. So that same goal exists of moving the variables to one side and the numbers to the other side, the constants to the other side. Let's pop those. Next slide we'll pop in those rules. Let's go through this here real quick though. The solution of this. So my goal here is going to be to get variables on this side, on the left side, and numbers on the right side. Notice when I say side, I'm talking about that, going straight down the equal sign. So, original problem, make sure you copy down correctly. 5x plus 2 equals 2x plus 14. I'm going to go ahead and we're going to move that 2x over here. So to do that, I undo, right, it's positive, so I subtract 2x from both sides. So 5x minus 2x is 3x. Over here, the 2x disappeared, so it's just the 14 left over. Now it looks like the ones we've been doing. I want to get that 2 over here, so I undo addition of 2. Subtract 2, bring it over here. So 3x equals 12. Divide off 3, x is 4. And again, the check, you go back, the original equation, take that 4, plug it in here to the original equation and run it through. Not something down here, through the original equation. Alrighty, what is the solution of 7k plus 2 equals 4k minus 10? So again, make sure we copy down correctly. So if we're thinking those steps, let me pop those in real quick here. Just going to make sure you copy it down correctly. So we're going to write 7k plus, that's a k I promise, there we go, plus 2 equals 4k minus 10. And so you got to make a decision. Where do you want the variables to go? Where do you want the numbers to go? I'm going to draw my line here. It helps me kind of keep it straight when I get longer ones like this. So I'm going to start out. I'm going to move my numbers to the right, my variables to the left. So subtract the 2 from both sides. So I get 7k equals 4k minus 12 because negative 10 minus 2 is negative 12. Now we're going to get rid of that negative 4k. Negative 4k, subtract that away rather. So I get 3k equals negative 12. Don't lose that minus sign there. It's a negative sign really. Divide off your 3, and k equals negative 4. And you can prove that. So I'll give you a second to look at that. Then I'll slide this out of the way so I can do the check, which I do expect from you. So you're going to have 7 times negative 4 plus 2 equals 4 times negative 4. Minus 10. On the left, I'm going to get negative 28 plus 2, which is negative 26. On this side, I'm going to get 4 times negative 4, which is negative 16, minus 10 more is negative 26. So my answer was correct. I'm going to skip over the part B because it's the same here. So write an equation with variables on both sides. Sometimes you got to write your own. It takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours, but it takes 8 hours to learn the software. How many web pages could the designer have to make in order to save time using the new software? So the idea is, again, you've got 8 hours wasted to begin with, and not wasted, I'm sorry, used up to begin with in learning the software before you can start making the video, or making the websites. So current design time, right? Equals design time with the new software plus time to learn the new software. So you want to know when those two are equal, when it's flush, right? Don't forget that let statement. Let P equal the number of pages the designer needs to make. So 1.5 hours for each page equals, and again on this side, 1.25 of the new software plus the 8 hours of learning time. So that yields this lovely, lovely two-sided equation. And again, we can solve that. Subtract off the 1.25 to give us 0.25p, leaving the 8 over here. Divide off the 0.25. 8 divided by 0.25 is 32. So by the time you break even, it's 32 hours to make it equal, 32 pages rather, to make it equal. Don't forget to label that as well. When the time savings, by the way, comes at the 33rd page is time savings after that. Alrighty, new problem. An office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $112 to $88. And how many months will the copier pay for itself? So we start off with that let statement. Let M equal number of months. There you go. So we do know that currently it's $112 per month, and the new one's going to be $88 per month, plus that $650 spent on the new copier. So solution here, subtract the 88M from both sides. That leaves us with 24M over here on the right side, just 650. Divide off that 24. And M is, it's like 27.08, right? So 27.08. So it's about 27 months. Don't forget to label there. About 27 months. All right, so this time using some grouping symbols, parentheses here. We talked before about distributive property, so this time you're going to be using it. So taking your steps, make sure you copy it down correctly. Then you distribute. 2 times 5x is 10x. 2 times negative 1 is negative 2. 3 times x is 3x. 3 times 11 is 33. So we need to move the x's over here to the left, so subtract the 3x from both sides. 7x minus 2 is just 33 on the right side now. Add the 2 to both sides. 7x is 35. We're almost there. Now it's time for the division phase. Divide off the 7, or multiply divide phase, I should say. Divide off that 7, and x is 5. Again, you'd plug this 5 back in to both sides to show the check there. Alrighty, on this one, start out by making sure you copy it down correctly. That's pretty important. I'm going to draw that line down the middle. Help me keep track of that. And we're going to start out with distributive property. We got to use it. 8y plus 4 equals 2y minus 26. So again, multiplying by everybody inside of each of those. I'm going to go ahead and subtract off the 4, subtract the 4. I get 8y equals 2y minus 30. Because negative 26 minus 4 more is negative 30. Subtract the 2y, subtract the 2y. As promised, that's a 2y. There we go. So I get 6y equals negative 30. Divide off that 6, and y is negative 5. There you go. Alrighty, another multi-step equation. And again, please make sure you do copy it down correctly. I'm going to zoom in here just a little bit. I would have to recopy it, so, there you go. That way for sure it's correct. And I'm going to draw that line I like to draw to keep track of stuff on these. So let's get started. We've got, first thing is distributive property, right? So thinking back to our steps, make sure you copy down correctly, then distributive property. So let's do that. The 7 gets distributed to everybody inside on the left, so 28 minus 7a equals, and then the 3 to everybody on the right, 3a minus 12. Now we're ready to think about moving stuff around. I'm going to move the variables to the right this time. Why not? So let's have some fun with that, right? I know you're all excited. 7a, so plus 7a. Again, remember to add the same thing to both sides. On the left side, that gets rid of, obviously, the a's, so I have 28 equals. And on the right side, 3a's plus 7a's is 10a's. Minus 12 just comes along for the ride. Add your 12. Add your 12 again to both sides. On the left side, I'm going to get 40. On the left side, right side, 10a. Now we're down to the multiply and divide phase. Just got to get the variable all the way down to it by itself. So a then equals 4. And again, the check will bear that out. And when you do that, as a reminder, you're going to have 7 times 4 minus 4, right, equals 3 times 4 minus 4. 4 minus 4 is 0, so 7 times 0 equals 3 times 0. And 0 does indeed equal 0, so my answer was correct. Just when you thought it couldn't get more fun, we can do other weird things, like say, oh, there's no solution. Or we'll talk in a minute about infinitely many solutions. So sometimes there is literally no solution that works. And you have to pay attention to the pattern for that. So we start out with this example. We have 10x plus 12 equals 2 times 5x plus 6. Now, as a good student of mathematics, obviously you would distribute, right, the 2 over here. So I get 10x plus 12 equals 10x plus 12. And it says because is always true, there are infinitely many solutions of the equation. So we're identifying, again, infinitely many and no solution. So in this case, Notice we get a statement that's always true. Now, let me kind of expand on that some more. It stops here. You go, oh, they're exactly the same. What if you didn't catch that? So what if you got to here and didn't catch it? They're exactly the same. So you would go maybe, and so I'd subtract 10 from both sides, right? Or 10x, I'm sorry. So 10x plus 12 equals 10x plus 12. And again, maybe you didn't notice that. So you subtract the 10x, subtract the 10x, and you get 12 equals 12. Well, 12 always equals 12, no matter what I do on this planet. So therefore, a statement that is always true, that gets us the infinitely many solutions. That means no matter what number I put into here. Let me say that again. That means no matter what number I put in here, any number will work. So if I go clear back up here and I put in a 1, I put in a 2, I put in negative 375,002, I put in 0.385. No matter what, it's going to work because both sides are exactly equal, always true all the time. Okay? So that is an equation with infinitely many solutions. Sometimes then we also get, let me get this out of the way for you here, we also get no solution. In this case, when you solve, you get an answer that is never true. Okay, so the two different kinds, one more time. When you get an answer that is always true, like 12 equals 12, it's infinitely many. When you get an answer that is never true, then it is no solution. No matter what I pick, it will not work. And let's take a look at that here. So 9m minus 4 equals negative 3m plus 5 plus 12m. And rightfully here on the right side, you're going to combine like terms. So the negative 3m plus 12m becomes 9m. And so I have 9m minus 4 equals 9m plus 5. And you subtract that 9m because they're not exactly the same, right? So subtract the 9m's, and we end up with negative 4 equals 5. Never, ever, ever does negative 4 equal 5 on this planet. So when you get an answer like this that is never a possibility, then you have no solution will ever work. I don't care what you pick, it won't work. But what I'm going to challenge you to do is take it all the way down. Every time, take it all the way down to where you just have two constants, right? And that's where you know for sure. Like up here, you saw me get 12 equals 12. So that means infinitely many. Down here, I got negative 4 equals 5. Never true. It can't happen. So if you take it all the way down to the constants and you're sure that your algebra and your math is correct, that you can be guaranteed that you have got a good answer there. Again, infinitely many and no solutions. Now, obviously, I've kind of given away the answer in this one already, but take a look at what I'm going to do here. I'm going to zoom in just a hair here, so again, I don't have to copy it down. And I'm going to draw that line to help me keep it straight. So on the left side, I'm going to go ahead and distribute. 3 times 4b is 12b. 3 times 2 is 6. On the left side, we're going to have negative 6 plus 12b. Now, you might recognize right now that they're the same statement, but let's say you didn't. So you go ahead and subtract the 12b, subtract the 12b, and you get negative 6 equals negative 6. Negative 6 always equals negative 6. I don't care what planet you're on. Therefore, this is infinitely many solutions. Okay, so again, you take it all the way down to just two constants, and if they equal each other, infinitely many solutions. Alrighty, so in this one, again, I'm going to zoom in so that I don't have to write it all out. We'll get that up out of the way. You can already obviously see the answer. I'm going to draw my line, and the left side we're going to leave alone for the moment. The right side, I'm going to distribute the negative 1, so I get negative 3 plus 2x. Subtract off that 2x, and I get 7 equals negative 3. So again, we're all the way down to two constants being equal, and they're not actually equal. So we say, well, it doesn't matter what number I put in here, it's never going to work. So that's how we get our no solution. Okay? So again, two types on these special kinds. When you get an answer that is never possible because you have two constants that are not actually equal, trying to tell us they're equal, that's no solution. And when you get two constants that are exact same number, like 4 equals 4, 10 equals 10, negative 7 equals negative 7, those are the infinitely many solutions. Alrighty, there you go, a little homework.